Okay. Hello, it's Keith from Kinvert, and I'm going to be doing a live coding session here. So my goal is to make a video of MNIST numbers blending from one number to another. So I've already done something before where I made an autoencoder and I found the latent space, and I can just show you here. So basically I'm taking a number and blending over to the next number. So I've already got this working, and I don't want to do it in the same notebook, so I'm going to do it in a new one, but I'm going to be grabbing chunks from this since this already works. And then another video I did before was this one, I think, yep, where I'm making all these numbers that go from blurry to not. And so in this one I really wasn't trying to train it. So this isn't running, that's why that's going to fail. This doesn't have the data in it, but it's basically, it looks like this. Hopefully that one's stopping here. There we go. Okay. So anyway, I'm going to start with this one. Okay, and then I'm just going to start grabbing stuff from here because I'm not trying to reinvent the wheel. So I can do my imports. I might have a couple other imports later. Okay, I didn't like the convolutional autoencoder, so I'll do this one. Let's see if there's anything that stands out. I think it's fine, and it's got the data augment. I'll do this twice so I don't have all the red. Okay, and then yeah, I can do this. I want to make sure that, well, I trust that it's going to work because it's the same. And so now we're into the training, and this one's a little different than the other because I'm doing the data augmentation. So let's see, optimizer, autoencoder should be the same, epochs, I'll do 50, 1024, epoch and range. Okay, this looks good to me. So we'll run that, and that'll just keep going. And now I got to figure out how I'm going to, so that's showing a result. This one is, this is blending from one number to another, but the problem is, what I did is I found the average latent space for this number, so it's kind of ugly, and this is the average latent space of 5. I want something more crisp like this. So this is like an average 2, and this is an average 5. I'd rather have just a 7 and a 4 in this case. So you can see that I did this, I blended from the one to the other, and then here I did something a little cooler, where I blended from the 7 to the 4 to the 9, and so it all just kind of blends together a bit. I want to get to something similar, but a video where it shows how it blends over time, if that makes sense. So we'll see if I can do it. I want to at least get it blending something like this in a video, but hopefully it depends on how long I go because I got to get to bed, but hopefully I can blend something kind of like this in a video, except it'd be the ultimate goal would have a 0 blend to a 0, and all these go down the diagonal blending to itself like a 9 blends to a 9. But right here would be a 0 blending to a 1, a 0 blending to a 2, 3, 4, and just get this whole grid where every number blends to every other number. So that's what I'm going to be going for. I just don't know if I'm going to get to it in this session here. Let me see what my, that's reasonably good. That should be good enough to get crisp looking images. Okay, so now blending from one number to another, so I'll grab this, and there's going to be similarities. Okay, so I am going to need to import OpenCV to make the MP4, so gridvid, there we go, and then import CV to here, and then So ultimately this is going to go away, but first let's make sure it works. It does. Okay, so now I want to be doing this, but I want to be doing a large grid like this, except it's not going to be linearly changing across. It's going to be doing the thing with the latent space changing, and I'm going to need a grid of latent spaces. So I'm going to have like a 10 by 10 grid, and within that 10 by 10 grid, each element is going to be a 7 by 7 or a 49. And then I'm going to be making a history of that. So this could get kind of big. But anyway, I'm going to want something like this. And eventually I'm going to want something like this. Okay, I'm going to want this sort of nested loop. I did a grid here, but this is different. So I'm going to go with something like this. And I'll be doing that later, but for now, I'll be grabbing like this. So it's going to be something like this. Okay. So here's my loop. So I'm going to replace that with this. I'll probably keep the plot. Okay, so this latent space, so this will go in. I'm not going to be doing multiple prints. I'm going to be assigning a single image, splits of 5. So let's see, first index, second index, but I'm really not going to be doing this for long. But I'm going to have total frames, and I'll go for 100 for now, and tiles is 10. I'm not going to be doing it with splits this way, so this will be total frames, MP total frames, tiles by tiles, uint total frames, I and tiles, tiles, this latent space. It's not going to be I, that's going to be total frames. This image decoder, this latent space, XR, I, no. And so instead of that, it's going to be like this. Something like this. I might be doing this one twice. It's probably gonna... I'll leave that for now. And then, yeah, I can do a print for each frame so I have an idea of how far along I am. Alright, we'll see what's messed up here. I'll get an error, something's gonna go wrong. Okay, blends, frame number, I, J, this image couldn't broadcast from 28 into that, so I gotta get like a 0 in here or something. Frame I, J, 0. Too many indices. This is just always fun with dimensions. Let's start from the beginning and make sure I got what I want at the beginning. So first of all, these are my old index that I used for the 0, or for the 7 and the 4, but I'm not really going to be using these now. What I'm thinking I'm going to do is just grab the first, sometimes my mouse double clicks, grab the first like 500 of these, should be enough to get that whole grid where I have 10 unique zeros, 10 unique ones, 10 unique twos. Theoretically, mathematically, you'd only need to get to 100 if they're perfectly spaced, but if I go to 500, I should have 10 of each digit within that amount. Okay, so then here, in counterpreds, this would be a 0. This would become a 48 for now. And we'll see what fails. And it still doesn't. So frame number, yes. Okay, so frame number. Let's take a look at this. So total frames. What if I just add a 1 here? Now it doesn't complain. Okay, so now it's doing the frames, and it'll show the result. Something will be wrong with the result. And then another thing is this is going to be coming in as floats. So we could see some janky stuff with this being a uint8. This is probably coming in as a float. It'll probably just seem like really low values, but we got to figure out what's going on. Okay, next time I do this, I should add a break or something. So I'm only doing a couple of these, because I don't mind showing an image that's mostly zeros and just show a number in the corner. We're only halfway there. So let's see, this is good, latent space difference. So this is where I got to get a bit creative, because I got to find some way. So the first thing I'll do is just literally take the first 100 of these, and I'll just go, you know, random thing to random thing. Now, if I make this like a 101, then I could blend each to its n+1. And then it won't be everything I want, but I'll have the proof of concept working. That looks good. That looks reasonably good. Okay. So total frames, latent over total frames. Okay, as type. Now, before I go too far, I will add the break. And I want to make sure that I can get this in the right format, because I have a feeling this is a float. And so we have this image is this, and then we got to go like dot numpy, I think, and then this image times equals 255, and this image is this image. It's already a dot numpy, a dot as type, np.uint8. Let's see how it works. Not great, Bob. Why did it fail so spectacularly? I would have thought that I would have at least gotten this, the top left number in there, is what I thought was going to happen. So decoder, this image, print this image. That's a whole lot of zeros. Do I might need to add another 0 after this. That was not the problem. See what I got? I would expect this, but I've got like an extra dimension there. So I add this 0. Okay, so let's get rid of this because I don't know that I need that, and let's print the image here. Negative numbers. How would I be? I shouldn't be overflowing it. This image decoder, I'm just straight up taking the output. You know, like frame number should be 0, so this should not be affecting it. I'll double check, but this should be a 0. Frame number should be a 0, and it is, which means that this should have no effect. This latent space, free shape, okay, 0 numpy. Maybe it's the batch norm at the output. Maybe the, oh dude, have I got to retrain? So let's do this. Yeah, I guess it didn't take that long to retrain anyway. And I'll go for 25 for now. Okay. Yeah, I'm getting negative floats, and I wasn't expecting that. I really thought I was going to be getting all positive floats. And so hopefully getting rid of that batch norm is going to do it for that. And then let's see, the blends. I like the shape of this. You know, it's a bummer I added the 1, but it seems to work. Oh, my fit is, it's not great, but I can keep training later. Okay, so now let's see if that got rid of the negatives. It did not. This is, yeah, I'm recording 15 minutes, okay? This is decoder, this latent space, dot numpy. Frame number is 0. But the image has these negative values. Dot as type np dot float 32. So 3.6 negative 3. Still the same. So that didn't change it. I don't know if I'm getting overflow. I'm getting negative numbers. Encoder preds, MP array of that makes sense. Let's print encoder preds. Just grab the first one, ditch this print. I mean, there you go. That's what I want. Right? That's exactly what I want. So, okay. My mouse double clicks. It's a Logitech mouse, and it just sometimes likes to double click like that. First latent space, and I don't need that, I think. That's all positive. So total frames tiles. So latent space difference. Okay, that's just subtracting the 2. Sure. Delta diff should not come in to play. So I have first latent space here. Let's make sure that this latent space is still the same. So here, and then this latent space. I got a 0 there, but overall, this is looking pretty good. I'm surprised some of these numbers are so big, and I'm not seeing any 255s, but I'm seeing 11s in here. I mean, I wasn't expecting that. So yeah, if I'm multiplying 11 by 255, who even knows what I'm going to be getting? Why would it be doing this? Let's see. Okay, I want to do this. Let's make sure that this is working here. I mean, that works. Okay. This looks fine. Counter. This one looked okay, but wasn't this? This might have been above zeros too. Okay. Yeah, these are above 0. These are above 0. Now, I mean, I got rid of the batch norm. Maybe I shouldn't have. What if I do this? tf.keras.layers. I think it's like that. And then I think it was like this. Something like that. Stop double clicking. Okay. Don't know if this is going to work. Okay, it's training. So yeah, that's bigger values than I was expecting. See, but this could end up all saturated too. I mean, I could just be ending up with all these ones where they might not belong. So we'll have to see how this one comes out after this trains and make sure that this still looks okay, because this is code that used to work in the other notebook. So I want to be sure that this still works. So my training, it's about the same. It's a little worse as far as my fit. That looks fine. Maybe a little darker there than it used to be. This is what I would kind of expect. But it's still not drawing jack diddly. Okay. So the encoder prediction looks like what I expect. Okay, good. And then let's check my latent space here. I'll just skip a step for now. There's a 1.0. Okay, there are some 1.0s and zeros and just normal looking, oh shoot. So there's a negative and a negative. They're tiny, tiny negatives, but they're still negative. So that could mess with some stuff. So this image decoder, blah blah. See, why didn't it show the blends minus? So I've got blends -1. Okay, let's go with a 0, because I'm skipping out on all that. Maybe that's why I wasn't getting the top. Okay, that looks okay. So okay, what if I do this? So I could just reduce the tiles and just get a cleaner looking. That looks fine. So yeah, this looks okay. All right, so let's get rid of the breaks as long as I got a small number. I can go with that. Okay, so I don't need this print. Okay. Yeah, my kid is sleeping, so hopefully, yeah, you should be able to hear me. Again, sorry, but this is the new format for now. I can't edit, and I just don't have time anymore. Okay, so blends is that. I've got total frames, frame of frames. Let's make sure I got rid of any prints I don't need. Blend frame. This doesn't seem to be needed now that it seems to work. Okay. Print that, show that. Okay, this might take a quick minute for the, oh, that's pretty quick. All right, because it's only doing the 2x2. So now we got blends, so we got a lot of blends. So 0, oh, this probably isn't blending to jack diddly though. Oh, it might be actually. If I go to 100, this might turn into a 7 or something. Still looks like 4s. Okay, so first latent space is that index. Second latent space is that index. Latent space difference. This latent space is first latent space plus total. Well, there you go. That ought to fix that part at least. And then instead of doing this over and over, for now I'm going to do that. So I'm not rerunning this just to print, or not print, but show. Okay, so this should look like a 4, and this should look like a 7. Okay, it's not a great 7, but I might end up training it a little bit more to improve that, but the principle is working. So now let's make sure that I can make the video, even though it'll be the wrong video. All right. So now I want to copy my MP4 stuff. Okay. This ought to be the MP4 related stuff here. Okay, that's like the codec. So I've got blends, and I need out is output. Okay. This will be grid blend 1.mp4. So printing I CV blend color map release. Let's quick. Okay, we'll see if this works. Where would this have ended up? All right. So this might be blur grid blend. Let's see if is that the right spot? So 7 to 4. Okay. So this is the format I want, and then I just got to get this to be 10 by 10. What time are we at? 26 minutes. That's not bad. Okay. So we're blending from the 7 to 4, and it looks good. So I can just save over that. I'll do the I'll give it a 2 so I don't actually save over it. This works, and this won't change. I'll leave that. Okay, so I'm happy with, let's save this. Okay, so now it's down to changing this. So now we want tiles of 10. And then delta. Now here's where it gets fun. We're going to have a lot of latent space differences. So we're going to have a grid of latent spaces and a grid of latent space differences. Okay. Because I want to blend a bunch of numbers to a bunch of other numbers. So how do I want to do this? So I set my tiles here. It's going to be dependent on my tiles. So I'll just move this down. This is going to change, but so total frames, yes. Tiles, yes. And then it's almost like I got a loop again, or because I don't want to do it every frame, so I do need another loop. Okay, so let's start that right here. Grid of latent spaces and diffs. Okay, so for I in, well, I can grab this because this will be the same. Shift tab, nope. Okay, now we are gonna grab an index, so pred idx is I times tiles plus j. I think so. And yep, things are in the screen. Okay. I times tiles, yes. And so then I'll call it this latent space, although I've called it that before, but this latent space is, and then we've got to get that. And I'm probably just gonna latent grid is np dot, or I'll go with zeros. Shape is, okay. So we're gonna have tiles by tiles. Now, maybe I'm better off just making a list and appending, because there's not only the grid of latent spaces, but there's the grid of latent space diffs. For now, I'm going to try this, and then this latent space, and then I'm going to end up at the beginning or the end. I'm going to have a problem. I'll worry about that later. Okay, so this latent space, and then encoder preds idx prediction index dot numpy, and then I went to 101, so next latent space is the same. Now I'm going to be calculating them. This is not going to be efficient at all, but I'm getting it. And so this diff is next latent space minus this latent space, and then latent grid dot append and so we will need this latent space and this diff. In between those, that ought to be enough information. And so now we're still going to need an index of the same type. And then this latent space, because now we're just making the image. So now this becomes, so first latent space is latent grid something. So this will be the index, and then the actual thing plus frame number times this again with a 1. This latent space, this latent space. It's close enough that I'm ready to try it. So, save. Alright, see what it does. This could be a little slow because it's 2 different sets of nested loops. Plenty can fail too. Latent grid space, preds index, must be. Okay, what if I do yep. All right. We'll see how this goes. There'll probably be something wrong with it. I don't think it should have been that easy. Okay, it's going. So What can I talk about? Yeah, so when I was getting those weird values and values that are way too big, I clamped the ReLU to this max value. And it seemed to make it fit worse. It gave me a worse mean squared error, but it's getting me the information I need in a format that I will be ready to throw it into OpenCV, because OpenCV is going to want it from 0 to 255, where like Matplotlib's imshow, it doesn't seem to care. It just seems to scale on the fly. I don't know if that's specifically what it does, but it seems to scale on the fly. It's done training, not training, but dumping all this out. Okay, let's try this. Okay, so I've got a 7 in the top left, and it should go to a 2. Okay. Okay. And this should fail, but a 99 should work. Wowie. And then a couple look different. Like they're not exactly the same. Yeah, it's clearly gone there, clearly gone there, clearly gone there. It just goes to shit quick. Latent space. Oh, I'm down here. Oh, I need delta diff. I overshoot. I overshoot my crap. This diff equals this over total frames. I'm overshooting. So literally by the second one, I forgot to do 1% per step. I do 100% per step, and then I do 100 steps. And so you can see that some of these are already screwed up, but I guessed it'd be a 7 to it. Oh, if I go to a 1, it should actually look okay, right? So it's going all the way in the first step. So I forgot to divide this. This diff is this. Make sure I'm doing latent grid, latent grid. This should work. Still worries me how smooth that went. Usually I have a couple other errors that I'm not understanding. And then it's getting late enough. I'll probably do another video another time where I actually get it to do the, well, it's this way for you. You know, the 0 to the 0, the 9 to the 9, 1 to a 1, you know, along the diagonal it's going to itself. And then like the 0 to the 9 would be over here, and get that grid where every type of number blends to every other type of number. So that will be probably another video, because I gotta chill a little bit and then go to sleep. If I go to sleep right away, I'm not going to be able to sleep, because I'll still be thinking about this. And I could train this more to get a cleaner look, but first I'm trying to just get the proof of concept. That's just old. That was just to confirm that nothing's broke. Okay. So blends of 0 should look like that, and then blends of 50 should look like half and halves. That's not bad. And then 99 should look like the final clean numbers, and it does. So now I'm ready for this. Okay, I don't think anything should have changed besides the file name. I think that's frames per second. Blends. All right. Do it. Wait, did it just... Is it that fast? Grid blend. That's not even quite a megabyte. Okay, is this fitting all the way? Move that. Okay. So the 7 to the 2, 2 to the 1, yeah, this is working. I don't know if I did a bad job fitting or if someone just drew a crappy, and what's that, a friggin' lambda? I don't know what that is. So yeah, I might want to end up training this a bit more another time so that the numbers come out cleaner, but this is just the proof of concept. But yeah, I've got all the numbers blending to the next index. And then the next idea would be to, you can see my mouse, this would be a 0 blending to a 0, you know, a 2 blending to a 2, a 4 blending to a 4. But up here, this would be a 0 blending to a 4. You know what I mean? And so I just have this whole grid where a 0 blends to a 0, a 0 blends to a 9, and every number blends to every other number. And so that'd be probably the next step. And in addition to that, maybe training a little bit more to get a lower mean squared error, cut that mean squared error about in half from where it is, because I like to have a mean squared error of about 0.007 thereabouts, and this one, not even the training data got that low, let alone the test data, and the validation is pretty high too. So while I'm checking things, I could run the training one more. Why not? And yeah, so we just imported like before. I had to make changes here. Keep output from going too high. Same here, right? And so that was a change. Left that alone. Random contrast, rotation, blah, blah. That looks fine. And then yeah, I'm training again. Oh, did it train fully? That was quick. So I've got that, but this is not doing great. And then this isn't going to be needed anymore. Yeah, I mean everything's working, so I really don't need that. It's the grid vid that I'm working on. Import CV2, this is all working. If frame 10 is 0, that'll just make it so I'm not printing so much. I don't need nearly that much prints. And then this I'll keep. And then the MP4 output, and I can do that too. If I10 is 0, okay, and that I don't need. See if we're okay. We're done training. Let's see how quick this is. Maybe this will be quick enough. I do it one more run to just see how things look. Zero. Come on, 10. Okay, it'll take a little while, but we can look at the pretty video for a bit. Yeah, so we got some sort of artifact there, but a lot of this, you know, this thing looking like a Y instead of, I don't even know what it's supposed to be. This is probably just down to the large size of my mean square error that I have, and I'll still have a relatively large mean squared error after this. It doesn't seem to be training that quick, and part of that really could be that I got rid of some of those batch norms. And so it could make it actually harder for me to get a good fit and get a low mean squared error. I could need to train longer. I could need to figure out, I might need to add more neurons. There's different things that I could try to get a better fit if I want to get this to be really pretty. But the main thing is I just wanted to get it working 45 minutes. Okay, so that's done, and now we won't really know, but this ran like super quick, didn't it? So I'll go to 3, since it's under like a meg. Pow, and close this, grab, so this one's just at a meg, 1.1 megs. Does this look better? I think this looks quite a bit better. Yeah. Yeah, not so many wonky numbers. That one's pretty bad. I guess it's a 3. But yeah, overall, it's looking pretty good. You can see all the numbers. Yeah, so got this working. Again, the next video probably is going to be me getting this in the grid with them all in order and blending to all the different numbers. Don't know how long that's going to take. It might be quick, actually. It's just down to sorting through and finding, based on the Y test, you know, the actual labels, looking at the labels, finding which numbers I want, shoving them in the right spot. And I've got to calculate the correct diffs and everything for each grid. And so I got to know, so I'm going to need like a grid of indexes. And so it'd be a tiles by tiles, so 10 by 10 grid, and each entry will be an array, and that array will be the index of the first number and the index of the second number, and then we'll find the diffs and everything from that. So that should work. Anyway, again, sorry for the new format. You know, I used to have more time to edit videos and stuff, and I just don't have time for that now, so this is the new format. And yeah, hope you found this helpful. It's time for me to go. Keith from Kinvert, and I'll see you guys later. Bye-bye.